Bismillahirrahmanirrahim. Scientific notation once again. Our previous video was interrupted for apparent no reason. I don't know why. The scientific notation was left in between. So let's start from the beginning. Scientific notation. Basically, this chapter is all about the techniques and methods to study physics. So, scientific notation is the continuation of those techniques. It is one of the techniques. It involves the numbers that have base 10. For that reason, we also call scientific notation as standard notation. Now, how would we identify if a number is in scientific notation or in standard notation? The two conditions, if a number fulfills the two conditions, we declare it as a scientific notation. We call it a scientific notation. Number one, there should be base 10 in a number. A number should have base 10. Second, the decimal should be positioned after first non-zero digit. The second condition is not a condition, it's rather a tradition, it's rather a convention. Second condition is a convention. Second condition is a convention. It's a convention. Let me explain with few examples. Let's suppose we have a number 0.0054. Let's suppose we have a number 0.0054. As per rule, the decimal should be placed after first non-zero digit. So the number becomes 5.4. So the number becomes 5.4. Now we have moved the decimal point 3 digits. 1, 2, 3. So it becomes 10 raised to power 3. And since it is moved from left to right, we place a negative sign. Similarly, let's suppose we have a number 5400. In this number, first step is to identify the position of the decimal. So in this case, when you see no decimal, it is understood that it is at the end. From end, we move it to the first non-zero digit. It becomes 5.4. We move the digit over 3. We move the decimal over 3 digits, 1, 2, 3. So again, the power is 10 raised to power 3. The digit was moved from right to left side, so it is positive. So it becomes 5.4 into 10 raised to power plus 3. There is a tricky case, an example. Let's suppose I am being asked to write a digit 5 in scientific notation. Write the digit 5 in scientific notation. The problem in this case is, as we mentioned earlier, when there is no decimal, it is understood that it is placed at the end. So the decimal point is already before the first, after the first non-zero digits. Now how would we write this number? So it can be written as 5 into 10 raised to power 0. We know that 10 raised to power 0 is equal to 1. So we can write it like this. Next topic is convention for using SI units. First condition, full name of a unit does not begin with capital letters. Again, this rule is against the rules of English grammar, where we always write the name of a person with capital letter. For example, 5 Newton. So look, N is in small alphabets. Similarly, we can write other units. Symbol of unit, second rule is symbol of unit is written in capital alphabets. For example, 5 Newton. Next rule is prefix is written before unit. For example, 5 kilogram. To see, kilo, K is before the unit, that is gram, or we write as 3 megawatt. So again, see, M is before the unit. Also, let's suppose next is, if we write more than one unit, if we have combination of units, we usually introduces a space between the units. For example, if I write the units of force, they are kilogram, meter, second inverse square. Now look, there is a space between kilogram and meter, and space between meter and second inverse square. In handwritten statements, we usually place a bar between the units. The next is multiple prefixes are not allowed. Multiple prefixes not allowed. For example, we can't write centi-milli-meter. This is not allowed. We can't write multiple prefixes. There is a rule: the power of unit is also power of prefix. For example, let me have an area of 1 centimeter square. Now look, square is above the meter, but it is understood that in reality it is something like this. So the power of the unit is also the power of prefix. Our next topic is error and uncertainties. Our next topic is error and uncertainties. In every reading, in every measurement or reading or experiment, there exists error. There exists error. So, what could be the possible cause of the error? What could be the possible cause of the error? We can place them under the following categories: inexperienced, or careless experimenter, operator. Somebody who is performing the experiment, he is inexperienced or he is careless. So there will be error. There will be an error. Second, faulty operators. Faulty operators. The instruments are not of good quality, or maybe they developed some type of fault or error due to the overuse or due to the for any reason it could. Next is inappropriate method. Inappropriate method. Keeping these conditions, now we are going to place the error in different categories. From the first condition or reason, we call it personal error. The error due to the person or the operator is personal error. Second could be systematic error. And the third one is random error. And the third one is the random error. Again, from the first type or first reason of error, we have defined the type, or we have made it a type of error, that is personal error. From the second condition, we have defined or we have made another type of error, that is systematic error, and from the third, that is appropriate method, we have a third type of error, that is random error. Now the complicated or a bit tricky error is the random error. रैंडम एरर बेसिकली हम लोग जो है प्रॉब्लम ये होता है कि हमें समझ नहीं आ रहा होता कि ये एरर किस वजह से आ रहा है। ये मुख्तलिफ वजूहात की वजह से आ सकते हैं। इस एरर के बाज़ औक़ात हमें समझ ही नहीं आ रही थी कि ये एरर क्यों आ रहा है या इसकी वजह क्या है या रीजंस क्या है। तो रैंडम एरर को मिनिमाइज करने का द मेथड टू मिनिमाइज रैंडम एरर इज टू इंक्रीज द नंबर ऑफ रीडिंग्स। तरीका उसका ये है कि आप जो है अपना डाटा बढ़ा देते हैं, आप अपनी रीडिंग्स बढ़ा देते हैं, जिसका हमें फायदा ये होता है कि हम लोग जो है उनका एवरेज ले लेते हैं, उनके जो है उनको समराइज कर लेते हैं और एज ए रिजल्ट हम उस एरर को मिनिमाइज कर सकते हैं या उसे रिड्यूस कर सकते हैं। बेशक हम लोग उसे ख़त्म ना कर सकें, लेकिन एटलीस्ट उसे हम लोग मिनिमाइज ज़रूर कर लेते हैं। तो हम लोग जो है इसका रेमेडी, रैंडम एरर कैन बी मिनिमाइज्ड, random error can be minimized by increasing the frequency of measurements.